All right, this is the final algebra packet for the distance learning, and this will be for the week of May 11th through the 15th. So we are continuing with quadratics, and for this day we are looking at the quadratic formula. So again, we have done this, should be review, definitely something you're going to need to know for next year or for Algebra 2. So some examples here. The formula is going to be listed on the next page anyway, but there's some examples of how we did this in case you forgot. All right, so we have to solve these using the quadratic formula. So remember, we are solving for the roots, which are also the x-intercepts, or the place on the graph where the parabola crosses the x-axis. So we would normally write this, and when we're asked to solve something, this should have an equals 0. And it has to be everything on one side, and it has to equal 0 in order for us to use the quadratic formula. So I'm not going to do all these problems, but I'll show you one just as a reminder. So first of all, we need to know what are the coefficients. So a, b, and c. So remember, this is for ax squared plus bx plus c equals 0. So we need to know that in order to use this quadratic formula. So the coefficient of x squared in this case is a 1. So a is 1, b is -4. So make sure we include the sign. So that's the number in front of x. So that's -4. And then c is also a negative, so it's -32. And then it's just a matter of plugging in those numbers. So negative, I'm going to write it all with parentheses first. So negative b. So b is -4. Plus or minus, because we're going to have two answers. Because we have two places where the parabola crosses. And then b squared again, parentheses, -4 squared minus 4 times a, which is 1, times c, which is -32. And then all over 2 times 1, which is a. So it's just a matter of just simplifying everything until we get to our answer. Okay, so x equals negative of a negative is positive, so 4 plus or minus. Now under the square root, probably do this in a couple steps. So -4 squared, that's 16. Okay, and then I see this next term is going to be a negative here, a negative times a negative, which is positive, and then 4 times 32. So 32 times 2 is 64, times 2 is 128. So that'd be positive or plus 128, and then all over 2. So 16 plus 128 is 144. That's nice. So we're going to end up taking the square root of that. So 4 plus or minus square root of 144, which we know is 12, right? So x equals 4 plus or minus 12, and that's over 2. So let's split this up into two different answers. X equals, we have 4 plus 12 over 2. And then we have x equals 4 minus 12 over 2. Okay, so the first one. 4 plus 12 is 16 over 2, so that gives us 8 when we simplify that, so x equals 8. Okay, the second one, 4 minus 12, so that's -8 over 2, which is, if we simplify that, -8 divided by 2 is -4. And then how can we check our work? So I think the easiest way is just to graph it. I'm going to take that original equation, so x squared minus 4x minus 32 into Desmos. Okay, so y equals x squared minus, was it 4x? Minus 32. So again, going back before we look at this. So going back, remember the numbers that we found are the x-intercepts, or the roots, or the zeros, or the solutions. Okay, so the curve should cross at x equals 8 and x equals -4. So x equals 8 is over here. Yep, 8 comma 0, and then -4 comma 0. Perfect. So that is the correct solution. Okay, so again, Same thing for the rest. Identify the coefficients and then substitute those into our quadratic formula and solve. Okay, the next is line of symmetry or axis of symmetry. It's just the mirror line that goes through the center of the parabola. And then they give us the formula. We've used this before. And we've used this in order to find the vertex, in which we will do on a later date. So it's just negative b over 2a. So that b in the a, that's the same as what we used over here for the quadratic formula. So the coefficients of those terms. And again, it's just substituting and then simplifying. All right. So we have a parabola. Number 2, it just says to multiply these together. So let's just do that one since it involves extra steps. So let's multiply this using distributive property twice, and then we can find the line of symmetry. So x times x is x squared, x times 8 is 8x, and negative 8 times x is negative 8x, and the negative 8 times 8 is negative 64. Combine like terms. Okay, it looks like that's going to equal 0, so we have x squared minus 64. So this is going to be one of our special cases. Do we remember what this is called? Okay, so think about it. Subtraction, so difference of squares. All right, so axis of symmetry. We have the equation up here, and we're going to need to know a and b. Okay, so the coefficient of x squared is 1. The coefficient of x, we don't have an x term, so it's going to be 0. And if we needed it, c is the negative 64. Okay, so then the x value for the line of symmetry, or the equation x equals, will give us a vertical line. So we substitute that in, so we get x equals negative b, so negative 0 over 2a. We get 0 over 2, which is just 0. So the axis of symmetry is going to be a vertical line along the y-axis. So it is symmetrical about the y-axis. So we need to just graph the line of symmetry. Okay, so let's label it. We get x equals 0. Let's do another one real quick since that one's a special case. Let's do number 3. So a equals 1, b equals negative 5, c equals negative 6. We don't need c, but it's a good idea just to write it. All right, so negative b, negative 5 over 2 times 1. Okay, so this is positive 5 over 2. So 5 halves, or 2.5, if we want to find it on the graph easier. So 5 halves, so 2.5, which is about there. And then we just draw that in. And that is x equals 5 over 2. So that's it. We're just drawing the axis, or the line of symmetry. But really, we would use this to help us draw the parabola. So we would need to know the vertex. We would need to know the x-intercept. So let's go back to number 2. Since that's already factored for us, we know that one of the zeros is going to be at positive 8, so about there. And also one at negative 8, which is here. So there's where it's going to cross the x-axis, okay? And then the vertex, well, we know it's going to face up, but we don't know where it's going to cross along the y-axis. So there is actually one more step that we could do to find that. Actually, we don't even need to do that because we know the y-intercept. And if we look at the multiplied the trinomial, well, in this case only binomial, but if we look at this, remember this number, just like in our linear equations, that constant term, or c in this case, is going to be our y-intercept. So it's way off the graph. So this is going to be a really steep parabola, but it will cross through 8 and negative 8. So it's going to go way down to negative 64. So we can't really graph it. But if we were asked to, then that's how we would do it. Okay, some interesting puzzles for you. Again, if you're stuck, leave a comment in Google Classroom. That'd be the easiest, and maybe another student could answer it. Or you can leave a comment on the video. All right, now we have our vertex, which is the next thing that we would find after finding the line of symmetry. And we have just one step after doing that. For this problem, now the example that I showed you before, since it was the vertex was on the y-axis, then we're just looking for the y-intercept. But if it's not like that, then we can't do that. So we have to do something different, and that is to take the value that we get for the line of symmetry, and then we plug it into the original equation and find our y value, and then that will give us our coordinate for the vertex. So it all is explained here on this page, but let's see if we can do it. All right, I'm gonna do number 2. So we need the line of symmetry. Okay, and then we will use that value to find the actual point for the vertex. And then we can just, estimate the probability, at least understand what it's going to look like approximately. We don't know the x-intercepts, or we don't know the zeros unless we were to factor and solve, but we don't really need to do that. So let's just focus on the vertex. All right, so again, we need to know a, which is 1, because there's nothing, right? So there's an invisible 1 in front of x squared, and then b, we also have a 1, positive. And then we don't need c, so I'm not going to list it, but it's -6. So we have x equals negative b, -1 over 2 times 1. So it's just -1/2. Okay, so -1/2 is here. Okay, so be careful when you're graphing this. So there's that. So it's going to be along that line somewhere. That's where we're going to find the vertex. And we know it's going to open up because the number in front of x squared is positive. Okay, so we have -1/2. So we want to know the y-coordinate for that. So I'm going to substitute. So I have y equals, and then wherever there's an x, I'm going to put a -1/2. So -1/2 squared plus -1/2 and minus 6. So I'm just substituting that x value in the original equation. Okay, and then we just simplify it. So -1/2 squared is positive 1 over 4. And then minus 1/2. Okay, but we're going to need to combine this. So we're going to need common denominators. So let's think about this in our head. So I have -1/2. So instead of -1/2, I'm going to minus 2/4, which is the same as 1/2. It's an equivalent fraction. And then instead of minus 6, I'm going to do minus 24 over 4. So we have common denominators, so we can combine those fractions. So y equals, numerators, we have 1 minus 2 minus 24. Okay, so 1 minus 2 is -1, and minus 24 is -25. Again, if you're not quite sure, you can use a calculator just to check your work. Okay, now we have this fraction, so it's going to be about -6. Okay, which is on our graph. But let's get a decimal just to make it a little bit easier to find it on the graph. So -25 over 4. So I'm going to divide that. So 25 divided by 4, 6.25. So that'd be negative y equals -6.25. Okay, so on our graph, it's about there. So that's our vertex. So let's label it. So y value is -1/2, comma, -25 over 4. It's always better if you put the fractions, but if you wrote it out like -0.5, comma, -6.25, I mean, that's fine too, but sometimes we have repeating decimals or, something that doesn't work out. So fractions are the best. And that's it. That's all we have to do. But if we were to kind of estimate, we know that it's going to be something like this. We actually know that it will cross the y-axis at -6, so that's a point there. So it's going to go up something like that. But we don't know where it's going to cross the x-axis. Anyway, that's all we have to do. Find the point for the vertex. And then draw a dashed line for the line of symmetry. Okay, next day, we're going to kind of put it all together, graph everything. Again, we've done this lots of times. In fact, we might have even done these same exact problems. So it says to make a table. Okay, so remember when we did this before, we could choose our numbers, but think about what our graph looks like. It's kind of a hint as to what numbers we choose. So I'm gonna do number 2. So first of all, what should this look like? So think about the coefficient of x squared. So what value is a? A is negative, so it's going to open down. Okay, and we also know that it's going to cross the y-axis at negative 1, 2, 3, 4. So we don't know if it's going to be over here or over here. Okay, so we're going to get that by finding some values. All right, so I'm going to make a table, just an XY table. And my x values, I don't need to do anything that's off the graph. So I'm going to do maybe negative, 4 through positive 4. Oh, I'm sorry. I misspoke earlier. I don't know if I said it's going to go like this or like this. But anyway, yes, opening down. Okay, so let's just choose. Let's just go negative 3, negative 2, negative 1. 0 we already know, and then 1, 2, 3. So 0, comma, negative 4. We know that, right? Because that's our y-intercept. Or we could just test it. We put a 0 there for x, and we get y equals negative 4. Let's try, let's do the positives first, maybe. So substituting in, we get y equals negative 1, and that's negative 1. Got to be careful with our negative sign here. So that's negative, and then 1 squared, and minus 4. So it equals negative 1 minus 4, which is negative 5. Okay, so that's 1 comma negative 5 right there. Okay, let's try add 2. So we get negative and then 2 squared minus 4. So that's negative 4 minus 4, which is negative 8. So be careful with that negative sign. We're not going to include it inside the parentheses. Okay, it's in front of, it's not part of it. So we need to do the squaring first and then make it negative. So negative 2 comma negative 8, or 2 comma negative 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it is definitely opening down. And then 3 is going to be negative 13. That's off our graph, so we can't plot that point. Okay, so moving up. So we have negative 1 we're substituting in. So we have negative 1 squared minus 4. And then that would be a negative 1 minus 4, negative 5. Okay, I was symmetrical about the y-axis. Because of course it is, because there's no middle term. Okay, so using this, we could probably figure out what negative 2 is going to be. It should be negative 8, but let's try it. So y equals negative, and then negative 2. Negative 2 squared is 4, negative 4 minus 4. Yeah, that's negative 8. Okay, and then negative 13. So there it is. There's our parabola opening down. And that's it. So again, choose your x values for your table based off of the graph that you're given. Okay, and then just a little bit more practice doing the same thing, making a table, almost the same kind of questions or the same equations. Again, double check your work in Desmos just to make sure that you got it right. Okay, some more puzzles, and then the final day of the week, May 15th, we're going to, looks like just kind of graph everything that we've done so far. So line of symmetry, vertex, y-intercept, x-intercept or the roots, everything. All right, so let's first find the roots, which we did last week, the line of symmetry, and the vertex, and then a table of values. So this is almost exactly like some of our tests that we've had. And then it does say, don't worry about graphing. Okay, so we just need some points in a table, so don't worry about the graph. All right, so what's the first thing it says? So find the zeros, or find the x-intercepts. So I'm going to factor this. Okay, so we have x and x. And then remember, we need, okay, so those are both positive in there, so that's going to be plus and plus. So factors of 6 that will add to make 5. So we have 1 times 6. If we add those, we get 7. 2 times 3, if we add those, we get 5. So 2 and 3, or 3 and 2, it doesn't matter where you put them. And then remember, we had to split these apart when we solve for this, okay? We don't just think of it that way. It's really equal to y. So we're going to set it equal to 0 because we're looking for the zeros. And we solve. So we get x equals -2 and x equals -3. So there's our x-intercepts. Okay, so it's going to cross through that. So we can imagine, again, we don't have to graph it, but we have -2, -3, and it's going to open up. So it's going to be something like that. Okay, but again, we're not graphing, but just, always try to visualize it. And then line of symmetry. Okay, so we have A equals 1, B equals 5. So x equals -5 over 2 times 1, which is 2a, -5 over 2. Okay, which is -2.5. And then we need a point, because we're going to put this in a table eventually. All right, so we need to substitute that into the original equation so we get the y value for that point. Okay, so y equals, and then we have -5 over 2 squared plus 5 times -5 over 2, and then plus 6. Okay, so we have 25 over 4 plus, it's going to be a minus because we have a positive times a negative. So let's just go ahead and write that as minus 25 over 2. And then common denominator should be 4. So let's say this is 24 over 4. Okay, and then that -25 or minus 25 over 2, let's go ahead and change that to a fraction that has a 4 in the denominator, which would be -50 over 4. Okay, so looking at this, we have 25 positive and 24 positive. So we add those together, we get 49 positives, right? And then we have -50. So that's going to just give us a -1 when we're all said and done. Or you can use a calculator. 25 minus 50 is -25, plus 24 is -1. However you want to think of it. I just changed the order a little bit. And we get y equals -1/4. Okay, so let's put these in a table. We'll start with y equals x equals -3. So for those x-intercepts, what is the y value for the x-intercept? Well, it was 0. That's what this value is here. That's the y. So that's 0. And then what's coming next is this here, which is -2.5 or 5/2, comma, -0.25, which was this. So that's our coordinate for our vertex. And then we moved on to the other 0. Okay, so that would be that. So think of what's happening here. So we plotted this point, we plotted that point, and we plotted that point, and now it's kind of cruising back up. So what would be the point where it crosses the y-axis? That would be here at 6. So 0, 6. Okay, so there's 4 points. So with those 4 points, we could graph this parabola. And because we know that it's symmetrical, so there's this 6 there, and then we could find this value, okay, because it's symmetrical. And if we had graph paper, we could figure it out pretty easily. All right, but again, we're not graphing it. We're just kind of visualizing it. So this would be good for me. I would like maybe a 5th point, but if we needed to, we could just choose any number we wanted. So like, what if I wanted just a 1? So what, x equals 1. So then we substitute in. So we get 1 squared plus 5 times 1 plus 6. So 1 plus 5 plus 6, which is 12. All right, so there you go. 6 points, 5 points. And that would definitely be enough to see what this looks like. All right, so that's it. One more week after this, I believe. And maybe there's 2 weeks left. Yeah, 2 weeks left of school. But that's all for the second week.